Hello everyone. Today I am going to discuss coherent sources. We use two coherent sources in order to explain interference phenomena. Coherent sources are not the real sources of light. Okay? So at first I am going to explain the condition for two sources to be coherent. So let me write over here. Two sources of light are said to be coherent if they emit light waves of same frequency, same amplitude, and in phase or constant phase difference with each other. So the condition for two sources to be coherent are they must emit light waves of same frequency, same amplitude, and in phase. Clear? So let us take a real source, okay, as this is a real source, and let the source be monochromatic. Now what is monochromatic source? Okay, monochromatic source, it produces, okay, this is a monochromatic source, okay, it produces light waves of same wavelength. Okay, the wavelength is constant for monochromatic source. Now let us take a screen, okay, and let us take another screen. So this is a screen where we want to study the interference pattern. Okay, now I am drawing a horizontal dotted line, and this horizontal dotted line act as an axis. Let us call this point as C, okay, and C represent the center of the screen, okay, and we get interference pattern above C and below C. Okay, I shall be discussing interference pattern in detail while discussing the theory of interference. Clear? Now let us make two narrow hole, one above this horizontal line and another below the horizontal line at equal distance from this horizontal dotted line, and let us call one narrow hole as S1 and another narrow hole as S2. So S1 and S2 are the narrow opening, okay, on this screen. Clear? Now light from monochromatic source falls on these two slits. Okay, so I'm writing over here S1 and S2 are the slits. Okay, these are the slits, or these are the narrow opening. Clear? So light from the monochromatic source falls on the slit S1 and S2, and they emerge from the slit S1 and S2 and falls on the screen, due to which we get interference pattern, okay, on the screen. Clear? Now while studying interference, we assume medium between slits and screen to be homogeneous. Okay, So the medium between slit S1 and S2 and the screen is homogeneous. So light emerging from the slit S1 and S2 have the same wavelength as that of the monochromatic source, that is S. And since the medium is homogeneous, the wavelength do not change. Okay, the emergent light wave will have the same wavelength as that of the real or original source of light. Clear? And these two slit, that is slit S1 and S2, act as a coherent source. Clear? So let me write over here. So these are not the real source. Okay, so slit S1 and S2 are called the coherent sources of light. And we also observe interference between the slits and the screen. We can observe interference phenomenon in between the slits and the screen. Clear? This is also to be noted. Now let us compare interference pattern with the standing wave pattern. Okay, so I am writing over here. Comparing interference pattern with standing waves pattern. Okay, clear? And standing wave occurs in string. Okay, vibration of string. Clear? So interference phenomenon is three-dimensional. Okay, whereas vibration of string, which produces a standing wave pattern, is one-dimensional. Okay, so standing wave pattern produced in a string is one-dimensional phenomena. Clear? So this is to be noted. Clear? In case of interference, we have maxima for constructive interference and we have minima for destructive interference, whereas in case of standing wave we have antinode. Okay, so I am writing over here, we have antinode. So let me write over here, we have antinode which represent the maximum amplitude. Okay, and we have node, okay, which represent the minimum amplitude. Okay, antinode for maxima and node for minima. Clear? And for interference there is net transfer of energy from slits to screen. Okay, whereas in case of standing wave in string there is no net transfer of energy. Clear? So I am writing over here, no net transfer of energy for standing wave. Okay, so these are the few points to be noted. Okay, when we compare interference with the standing wave pattern. So only this much for today. Please do like, comment and subscribe my YouTube channel. You can also follow me at my Facebook page @JIWAN PHYSICS. Thank you.